Good morning everyone to Makaut electrical engineering channel. So today we are going to study about resistors, inductor, capacitors. Along with this we are going to study about their properties, their their equations for their powers, their energies. Okay. So resistor. Resistor. So what is a resistor? So it is an electrical component. It is a electrical component. It is an electrical component which opposes flow of current. So basically it is electrical component. Okay, and what does it do? It opposes flow of current. Electrical component which opposes flow of current. So how does a resistor look like? Simple. Take one terminal. For example, there are two terminals. We want to connect a resistor. Okay, so just simple, draw a line, zigzag, 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 zigzag. Okay, so this is your resistor. How do we denote a resistor? We denote a resistor through R. Okay, R. Okay, so for example, this is resistor, a current I is flowing. It is a function of time. Okay, I of t is a current which is flowing through a resistor. Okay, so how we are going to write this equation? We know that from Ohm's law, we know that V is equal to IR. Yes or no? V is equal to IR. So V, what is V here? For example, if current is flowing I, so the voltage must be this along this resistor must be V of t across this terminal, right? So if current I is flowing and potential difference or the voltage is V of t, right? So we know V is equal to IR. V is given here is V of t, right? I given I of t. Then finally your R. Can we write? So we found the equation of voltage for a resistor, that is V of t is equal to I of t into R. Next, power for a resistor. The equation of power for a resistor. So how can we find the power of a resistor? If you have seen my first video, you must know that power is equal to voltage into current, right? Voltage into current. So we know voltage can be written as IR. Yes or no? This I is already given. Okay, next, I into I can be written as I square R, right? We also know I is equal to V by R from Ohm's law only. V is equal to IR, so I can be written as V by R, isn't it? So I will be written as V by R square into R. This R cancels and one R remains, so the equation becomes V square by R. So we got the equation for power for a resistor, that is P is equal to V square by R. Next, energy for a resistor. So energy, the equation is E is equal to integration of power with respect to dt from time t1 to t2. Okay, so what we did, the power equation is given, right? You put this V square by R, integrate it from time t1 to t2, you will get the equation for energy. Okay, so this is the equation for energy. Next, now we will see some properties of resistors. Okay, for example, if there are n number of resistors, okay, and they're in series how we'll find the total resistance. Okay, so for example, first in series. Okay, so there are n number of resistors. For example, I take a terminal R1, R2, R3, dot. Finally, Rn number of resistors are there. Okay, R1, R2, R3, Rn. I need to find the total equivalent resistance Req, that is the total resistance in this circuit. Okay, so what will be Req? Your total resistance in this circuit, it will be R1 plus R2 plus R3 dot plus Rn. So the total resistance, we will just add all the resistances given in the series R1, R2, R3. Okay, now in parallel, for example, how we denote the resistors in parallel, like this. One resistor is there. Okay, so this resistor is parallel to this. Again, I am taking one more resistor parallel to this, then dot the n number of resistors which are connected in parallel, like this. Okay, so what will be the total equivalent resistance along this two terminal Req? So Req will be in parallel. For parallel, we will just divide it. 1 by Req is equal to 1 by R1 plus 1 by R2 plus dot 1 by Rn. For series, we just add it R1 plus R2, right, like this till Rn, and in parallel we just divide it 1 by R1 plus 1 by R2 dot 1 by Rn. So resistor is complete. Next, capacitor.